Hello, it's David. Now, people who've been following my channel for a little while will know that some time ago, probably about a year, I was doing a bit of work on the PiStorm project for the Atari ST. PiStorm, very popular Amiga accelerator where a Raspberry Pi 3 was used, in this case a 3A here, was used to replace the Motorola 68000 inside the Amiga 500. Running a software core and allowing great acceleration and other utilities such as access to virtual disks and network. Is really a very simple, cheap and effective accelerator, but it didn't work on the ST because of, well, primarily bus arbitration and bus errors, two things that the ST requires that the Amiga doesn't. So we managed to get that working, but it wasn't fast enough, it wasn't very stable. But fortunately, back around the end of 2022, I was speaking to Steve Bradford. Now, Steve Bradford is the man who designed the Raspberry Pi Pico-based ST hard disk emulator that you've seen me build in previous videos. By the way, this is working now with the STE. Have a look at my GitHub page for the latest information on that if you're interested in one of those. Although there is a commercial version which has fixed some of the bugs and has better firmware. That's available from the Exos store. Now, whilst talking to Steve about the Pico hard drive project, he mentioned, I wonder if the Pico would be capable of actually emulating a 68000 itself. I don't think it would, but I told him about the PiStorm project I've been working on. And he's a much more software-oriented chap than I am, so we got him on board, and really for the past 9 or 10 months he's been developing PiStorm for the ST pretty much by himself. I haven't had time to help him out, unfortunately, and sorry about that, Steve. Anyway, we've got it to a point now where with even a Pi 3, it does work with the Pi 4 now as well, and you get better performance. But even with the Pi 3, we've now got to a position where we can have HDMI graphics running, in this case, 640 by 480 at 16-bit colour. We've got 128 megabytes of TT RAM installed. Here we are running Mint from a virtual hard disk that's configured on the system. But we still have this problem where it doesn't really, does it, fit in the case. So let's have a quick look at the stack I've got here and what we can possibly do about it. Well, first things first, there's this HDMI cable that's running out the back just to do that output on my main monitor there. We can disconnect that because that's entirely optional. Obviously the PiStorm works just as well on your normal Atari video output, but you don't get all the fancy colours and high resolutions that way. So what we have here, this is an Atari STE, and we've got a PLCC to DIP 68K adapter. We've then got the PiStorm itself with extended headers, not needed for this particular board, but I've got them here for doing development work with a Pi 3B Plus and a Pi 4. And then this is a Pi 3A Plus here. This wire just supplies a little bit of extra current to the Raspberry Pi. So let's disconnect the adapter and I'll show you the stack. This is my PLCC to DIP adapter featured previously on the channel, and that's the PiStorm sat on top. You don't need the extended headers, as I say, for this one, and I do have another PiStorm. Here's a more conventional PiStorm format. The only reason I'm using this one at the moment is because it makes it easier to clip on the additional power, and also this is using flip-flops here instead of latches. This one has latches. There are different type of chips available, and all of Steve's work has been carried out with the flip-flop version. Not that I think it should make any difference nowadays. So with the PiStorm sat on there, and the Raspberry Pi on top. Even if we swap this out and put the lower profile Raspberry Pi in, I'll show you that basically the case can't close. There's no way, and actually the floppy disk with this particular combination of PiStorm and adapter, the floppy disk drive, also can't quite fit in. I've got a Gotek here mounted loosely, but a conventional floppy can't go in either. Sorry, let's just fit the Raspberry Pi. So that's the size of the stack, you see, and then that's going to clip in like that. And here we have the height of the keyboard. So there are two issues here. One, I think that probably is just a little bit too high for the keyboard to clear anyway. But two, there are chips here on the back of the keyboard, which when positioned, I'll just take my power lead out of the way, which when positioned correctly impact the Raspberry Pi. Yep, that's hitting there. So a better solution is needed. So here it is, the PiStorm STE, or, well, okay, a 3D printed version of it that's held together by insulation tape. But this is a model of a design that I've put together in KiCAD, which will be on my GitHub repository and the work in progress PiStormSTE section. The idea is that the PiStorm will fit in, the Raspberry Pi, sorry, will fit in this way round, opposite direction to the conventional PiStorm, allowing it to go back further into the case here, and this should slot in around this pole and into the CPU socket like that. Now obviously this doesn't stand up by itself, so I shall use this structurally sound support here in an appropriate position. There we go, to hold it in place, and we can pop the keyboard in and just double check that it sits nicely.
I'd like to thank this video's sponsor and the supplier of my project PCBs, PCB Way. PCB Way aren't just about PCBs either, although they are extremely good at that. They also offer component assembly, CNC machining, 3D printing, and a variety of other manufacturing services. They have a number of community-focused offerings too. The Shared Project Hub is an open platform for makers to share and exchange their ideas, and the PCB Way store is a great place to pick up assembled modules. I mean, who wouldn't want a musical Tesla coil? So many thanks again to PCB Way, and I recommend you have a look at some of the links included down below.
Okay, so our various orders have come back, and here's what we've got. So I have asked for 2 pre-built boards, but obviously just the SMD components. But unfortunately, the lead time on the flip-flops, we're using flip-flops on this board, was excruciating. So I decided to get it populated without those. So we need to add those on there. We need to put the through-hole header on here for the Pi, and we need to obviously do our PLCC adapter. So I should have 2 of those. Those are 3 remaining blank boards, so we've got 5 boards in total. There we go, yep, no, that looks all right. Orientation's correct on the chips. Regulator, all of the caps and resistors are in place, excellent. So great job, thank you very much, PCB Way. So then this is what we need to complete the set. We've got our flip-flops, and these are the flip-flops. So that's the 16374. My other board's 16373. We've got 40 position 2.5mm header for the Raspberry Pi, and we've got 20 position 1 row headers. This doesn't need 20 position, we'll have to cut a little bit off the end, but that was the nearest round number that we could get. Brilliant. So, well, let's start with the most awkward bit, which is the flip-flops. And I've ordered 6 of these, so we've got some spare. And we will, obviously, soldering in between those is going to be the hardest bit. Let's try and get that soldered up. Now, one thing that may not be obvious on the camera here, but I can tell you it is in real life, is that the pads here on the 4 chips have been tinned. So it's already got solder paste on there for the purpose of the wave soldering. So I don't know whether I should clean those off first or just try and use that solder. So I'm going to try to use the solder initially, and if that doesn't work, I think we'll get the solder braid out and clean it off. So I'm just going to try and line this up, which is always the hardest part. And in fact, it is actually quite hard with those pads pre-soldered. Yeah, it's actually quite difficult to see when the alignment is correct because they're proud. I think that's aligned. So I've got my iron here set to 290 degrees. I've got my chisel, no, not chisel tip, this is a K tip. I've got a K tip here, and I'm going to try and tag one end, but I don't know how it's going to work with this solder on here. Let's try it. So I'm going to try and apply a little bit of pressure and just tag one corner here. I'm just melting the solder. Yeah, okay, it's kind of tagged it. Moving it around slightly. I think, to be honest, I'm going to remove that, and I'm going to get rid of the solder. I suppose I could try hot airing it. Oh, it is lined up. Oh, shall I try? I think let's, for science, let's give it a try. So I'll get the hot air on in the background. Apologies for the noise here. So I'm going to bring the hot air in at about, say, 320. Always tend to go a little bit warmer on my hot air. Let's put a bit of flux down. I'll put my flux paste on this side, try and smear it around a bit. And again, for science, I'll put this cheap liquid flux on the other side. Okay. Now we're going to have to be quite gentle with the airflow here, I think. Otherwise, we could just blow the chip around a bit. Okay, so I think that is lined up. So, just my cheap air station here. I'm going to turn it down to about, it's 5 out of 8 units of blowiness. I'm going to try and hold that gently in place with my tweezers and try and melt one side, see what happens. I think that's melting. I think that's soldered. Let's try the other side. Let's try and turn it this way so you can see, maybe you can see it melt. Just apply a bit of downward pressure. If this works, I could still run the K-tip down it a little bit, I suppose. Well, look, I'll be honest, I can't see if that's melted or not. Might be more obvious on camera. I doubt it. But. Where are we? Over here. There we go. Yeah. I think that might have worked okay. I'm going to tell you what I'm going to do. I'm going to run my K-tip down it anyway. Hopefully that will just assure it. I definitely feel more confident with that, I'll be honest with you. I'm actually running the iron down the legs rather than the pads. Trying to make the leg which is sitting on the solder, sort of push down onto the solder. We'll see how that goes. I think that's okay. We'll try that again. Okay, now I think, to be honest, I'm going to just remove these this existing solder paste. I think it's just annoying me. Yeah, I think that looks better after a clean-up. Okay, time now then for the Raspberry Pi header. Pops in the top there. Bit of flux. Again, same kind of a deal, although this is through hole. So we're trying to keep it as flat as we can, and we'll just anchor a couple of points. Let's have an inspection. Yep, that looks 90 degrees enough for me. So now just a traditional bit of through-hole bucket soldering. Okay, so this is, in my opinion, probably the hardest bit of this build. These are the little tiny 1.27mm pitch single row headers. This is what makes a connection with the PLCC socket. Now, these are 20 pins long. They've got to go on the bottom of the board here, and you need to break 3 off the end to make it fit. And that in itself is tricky, so always buy more than you need, because it's very easy to accidentally. Oh no! Oh dear! There we go. I've broken 4 off. So there's different ways of doing this. I think what I'm going to do is to try and grip it at the point where I want it to. I do not want it to be damaged with the pliers like that, and then I'm just going to try and snap it off. Oh, 4. Exactly what I was saying. Look at that. The last one has sheared off. God damn it. Okay, well we can, that obviously didn't work. We can try a different approach this time then. I'm going to anchor it once more, hoping that is once again the correct place, and this time I'm going to nibble it off with the side cutters. They may never be found again. Okay. Well, that one did work. So let's do that 4 times. I'll have to get a spare out. Okay, there we go. That's how it's going to look. The plug's going to go down in the middle there. Now the problem is though, that plug is plastic. It's PLA plastic. That will melt at very low temperature compared to the soldering temperature. So I can't just pop that in there, hold it down and solder round. It will melt. So I think the best thing I can possibly do is to just anchor a midpoint as quickly as I possibly can on each 4 sides, and then check alignment. Yeah, this probably needs a few more hands than I have. So let's give this a bit of a go. I'm going to dot a blob of solder in the middle of each. Well, 3 for now. Each side, and this might be quite difficult for me to capture on camera. Sorry. Okay. Right, so how does that look in terms of alignment? If anything, you want them to be slightly more splayed than pigeon-toed, as it were. Right, so it's probably a good moment now to actually try and fit it into a PLCC socket. So I've got a PLC 68 here. You can see that the plug fits in like that. And the question is, how do our pins align? A little bit of a wiggle wiggle. Very difficult to see, but I reckon that's pretty good. Yeah. I think that's fine. Let's get that soldered up. Okay, and once again, it's very difficult to see if we've got any dry joints there with the amount of flux there. That all needs to be cleaned off. Don't think we've got any bridges. And if we look at the alignment, Well, this one maybe is a little bit splayed outwards, but that's okay. It will make more positive contact. This one I think is fine. This one is actually quite a long way splayed outward. That may be too much. I might have to correct that. And that one is a little bit splayed. So we do have a bit of a splay. I think we'll give this a quick clean up and just a very cursory wipe initially, and we'll just try and put that back in that PLCC 68 socket. Just want to get rid of the worst of this because I don't want to contaminate the socket, basically. Cleaning this stuff up is horrendous. By far the worst part of soldering. There we go, clunk. Good positive contact. There we go. Right. There she is. Let's get her cleaned up. Okay, so here we are back with the STE with its top off, and here's the board we've just built. Got a PLCC spacer in the back there. We'll mount our Raspberry Pi 3A Plus the correct way around, and we will attempt to slot her into the CPU socket, which is, perhaps because I had those pins a little bit splayed, is easier said than done. Yeah, I don't think I'm in the right place there, actually. There we go, clunk. Now, one feature that I've added to the PiStormSTE here is an auxiliary power pin. Now, that can be used to power a fan, because the Raspberry Pi does get hot. And I do have a little fan that I might glue onto the bottom of there. I've actually got a passive heatsink on the bottom at the moment, but an active fan might be better. So there's a power draw off that's available there, but that all pulls through the PLCC CPU socket, so it would probably be better to power that independently. This was actually intended as an auxiliary power in, so again, using my little clipper leads here, I'm going to run from the positive end of this main filter cap, just off screen, sorry. There we go, the positive end of the main filter cap here, and I'm going to clip that onto my auxiliary header. The positive side, it's clearly marked, the bottom one, the one nearest to me, is 5 volt, and that will just provide a little bit of extra power there for the Raspberry Pi, not having to pull through the PLCC header here. There's I think maybe 1 or 2 at best. 5 volt 1.2, no, what are they? 1.27 millimeter pins. Not a lot of current carrying capability there. Now here's the big moment of truth. Will the lid go on? The keyboard go on, I mean. Yeah, she's riding on something. Is that my... No, I don't think so. Let me take you out a bit there. She's on. She's firm. We're in. Okay, off camera I did actually just try to hook up my little HDMI lead here, but it turns out this is a bit too deep for the positioning of my board there, and it makes contact. In fact, basically it aligns exactly with where the SIM well, the first SIM is in the STE. So I'm going to forego HDMI for now. That's something that you maybe need a slightly different cable or a thin cable and go over the top of the SIMs. But let's try and fire this up just on the normal Atari display, and we'll see if we get any luck. I've got a green light here. Oh, I can't see the Pi now. Yep, we've got some flashing green over here as it's booting the SD card. Emitos version 1.2.1, 68020 Atari STE with 128 megabytes of TT RAM, 4 megabytes of onboard RAM, and 2 virtual hard disks. Beautiful. .68020 running at 96 megahertz, according to Sysinfo. We've got over 130 megabytes of free RAM. Excellent. Let's try Cormark. Sorry about that. I managed to press a button on the camera and inadvertently trip it into single frame mode. So there we go, that's finished. So Cormark iterations per second, 20.49. That's roughly on a par with my DFB1 in a Falcon, which has got a lot faster memory. Not the alt RAM, but the onboard RAM is twice as fast on ST. So I think that gets to maybe just about 22. So 20.4. So the sort of the whole all-round performance there is broadly similar to a 50 megahertz Falcon. That's not bad. Okay, so there we go. The case is on completely. It's not screwed in, but you can see that it's correctly fitted in each dimension. So let's have a quick look at that problem with the HDMI cable. Okay, so here's the problem. There's a gap here of about half a finger's width, so I'm going to say that that's probably about 6 millimeters between the HDMI output port and the start of the SIM slot. Now, to be honest, I had hoped that my little adapter here, which annoyingly folds the wrong way, this is a male to female little ribbon cable adapter here. Let's just unhook that. Yeah, this is a little flat flex adapter. But I was rather hoping that that would actually point upwards. But no, it points downwards. But also it's very, very long, and it's actually longer than the space available. So we end up with, yeah, kind of it's sitting there where the SIM wants to be. So that's not really going to work. I mean, if you're not using the HDMI, it's absolutely fine. Is that still a composite out? Could we get composite out from the Raspberry Pi? That would, look at that, I mean, that there's space there, that would work. I should say that the board is exactly 100 millimeters long, which is the price break point for PCB Way. Beyond that, the price goes up really quite rapidly. So I couldn't really move the Raspberry Pi any further this way, but that's actually fine. That wouldn't really help us at all. I could potentially have moved it a bit more that way, but then I'm always nervous about these chips over here and whether they would start interfering. We might have, yeah, no, I probably couldn't have quite gone far enough back that way. Then it starts to get very tight with the pin routings and things. So I think we're kind of in the right place there, but we almost need to angle the board up a bit. I don't think we could solder the pin headers at an angle, but, oh, it's popped out. Let's take that out. If anything, that's folded down a bit. Yeah, we almost want it to fold up, not by very much. Could potentially make it a little bit taller. What about if we tried with taller pin headers here? Okay, so I've got my second partially assembled board here. Obviously this doesn't have the pin headers for the socket in here, so we're going to have to pretend on that end. But I've got these old PC104 style long pin headers. Now I'm not really interested in the length of the pin headers, but they do have a tall extra spacer there, you see. Now if I were to pop these in here, all the way down as if they were flush, because you could always cut these off, you see that that is actually now a taller header experience than that one. Would that still fit in, therefore, I'm wondering? There we go. Can you see the problem with my little experiment there? There's actually about a 2.5, 3 millimeter gap here because the pins are grounding out. Okay. I would probably actually have to solder that up for real, wouldn't I? Well, this is potentially another option. This is a Raspberry Pi 2 or 02, which has the same chipset and should work with PiStorm. Don't have any headers on this one, so I can't actually fit it. But let's have a look. We've got there's pin 1 up there. Pin 1's down there. Ah, yeah, it goes like that. There we go, that way around. So that would fit in that direction. So that would go in something like that, and then, well, firstly, that's micro HDMI, or sorry, mini HDMI. So the cable's normally a little bit smaller anyway, but also look at that clearance you've got there. Okay, well, I think I'm going to leave that there for today. PiStormSTE, that's the board that I've designed primarily for the purpose of doing testing and development work on the PiStorm here for the ST series. If you're interested in this, it is going to be available on my GitHub. I'll put the link in down below. At the moment, that's in a work in progress branch, but maybe I'll just bung the files out into a release so that they're easier to find. So check the links down below. Thinking about maybe doing a second version of this with a cutaway here to allow the Raspberry Pi 4 to fit natively. The problem with the 4, a bit like the old 3B, it's got this big old Ethernet port here which is fouled by the board. If I were to relocate those buffers to the bottom side instead, I could have a cutaway there, maybe it would fit, but actually the routing is very, very complicated. You can see that we've got an awful load of signals coming down here, so that would actually be quite a hard respin, and you can see it really doesn't fit very well. The traditional solution is you desolder your Ethernet port there, and the advantage to using a Raspberry Pi 4, which is actually the primary development platform for the PiStormSTE at the moment, the advantage of using Raspberry Pi 4 is it's faster. We've always been up against the limit of memory access speed. It's only recently that the PiStorm 3 has been able to get up to the 3.7 megabytes per second that you normally see on the ST series, and it's still in flux. The PiStorm project at the moment is still, for the ST, is still very much a work in progress. Please do join the Discord chat server if you'd like to help out, if you'd like to test. All the instructions are on the Atari channel there. That's why this is not just a silver bullet, the Raspberry Pi 2.0, because this is a stock frequency of only 1 gigahertz. These ones are stock frequency of 1.4. I can't remember what the Pi 4 is, but it's higher still. And the emulator performance, when doing the things required for an ST, like bus error handling, is really, really touch and go as to whether it can keep up with the 3.7 megabytes per second that the ST needs. So some days a little bit of development might come through and the speed drops off again, and then we'll chase the differences and the speed will go back up. So it's right on the cusp of working with the 3 series at the moment. The Pi 02 is the same chipset as the 3. The 4 doesn't really have that it's got much more overhead, but as you can see, it's harder to fit the whole. There's no 4A as far as I'm aware. They've just announced the 5. Raspberry Pi 5 is not going to work anytime soon. It would need to use the secondary memory access or something. The GPIOs are just too slow on the Raspberry Pi 5. They've gone down a different road. So this is the best design platform, but you won't get it to fit inside the case. This one you can get to fit inside the case, but HDMI access is going to be problematic. You might need a really skinny cable, but you may be able to do it. This will definitely fit in the case with a PiStormSTE, but it may not be fast enough. So there's some swings and roundabouts. Come and join the chat. Come and have a bit of a test with us. And just out of interest, would having that tall header help at all with fitting the 4 in here? Clearance is oh, you know what? Oh, it doesn't quite go, but you know that's as near as damn it. I've already got a bit of insulation tape on here to stop it shorting out anything. Oh, that's close. That is close. I'm going to have to solder that up, aren't I, and see how that fits inside. That, oh, if we can make that work, mind you, this uses micro. Which one there is that? It? No, that's the USB-C, isn't it? Where's the video out? Are these both video outs? I don't know how it works with the Pi 4. These are micro HDMI outputs, I think. I don't know. Maybe you can get a little tiny cable that would snake its way over the top of the Sims. Not sure. Anyway, that's the state of play in the PiStormSTE world. We've got a new board specifically for the STE. I hope people find that useful. Stay tuned. Thanks for watching.